In this section, we begin our study of how WinServe deals with proximity. There are various tools in WinServe that are available for you to figure out how far away you are from other wells or from your proposed path. And I start out with a file here, which is a horizontal file. And I'm going to go to the plot here, and I'm going to show you what it looks like. This is the profile from the vertical section view, and this is the plan view right here. And I'm going to zoom in on this plan view, and we'll take a closer look at what it is we're looking at. We have the red line here is the proposed path. The green line is, we're going to say that's a parallel path, or it's for the purposes of displaying another well. I just basically made a copy of the proposal path and put it over there so we can take a look at it. And the black path is the path that is being drilled. So we can see that now. We can do things. For example, even in this zoom, we can figure out approximately how far away we are from something. I can just click down at the end of this, and I can draw a perpendicular line over to the red one, and I can see that I'm about 10 or 11 feet away from the proposed line, and I'm about 6.7 feet away from the green line. So I have a pretty good idea of how far away I am by just graphically looking at it. But that is a two-dimensional view, and it can be misleading, so you don't depend upon that. Another two-dimensional way of tracking it is to use this tracking here, and we can come up here and we can see. I'll track least distances here, and I can come up here to the end of my black line, and I can look at my numbers being displayed up, and I can see rounds off numbers, and I'm 11 feet away from the red one and 7 feet away from the other one, which is pretty much in agreement with what I saw before. So I have a quick way of looking at it there as well. And then there is getting back to the main screen here, we can see that there's another distance here, and that we're in curve 1, or is curve 0, and curve 1 is the curve, the proposal, and curve 2 is another well, and we can see that it's offset by 12 feet to the north and 12 feet to the east. So it's gonna be parallel to us, but offset pretty much all the way down. And I'm coming back to here, and we can look here at this 4,004 foot survey that we have here is our last survey. And when we put that survey in, we can look here and we can see that we're about 10.9 feet away, 11 feet, just like it said before, from the proposal curve. And if I put in 2 as the comparison curve, which is the green curve, then we can see it says about 6.83. So all these are in very close agreement with each other, even though they use slightly different methods of estimating it. They are all give you a good idea as to how close you are. Obviously, if you're going to be checking to see how far away you are from the proposal, you want to get as close to your proposal generally as you can. And if you're checking to see how far away you are from another well, you generally want to be as far away from it. So different reasons for knowing these numbers. If you want to see how far away you are from the bottom hole location, you click on bottom hole location and then re-trigger this, and it tells you that projected distance down to the bottom that you would be this far away. But sometimes, well, generally, it's better to toggle these things on and off to make sure that they get calculated properly. Now, there's another very useful way of looking at more than one well at a time and how far away you are, and that's by using this normal button. And we're going to come here right now, and we're going to open up this screen, and you can see that this is looks like a traveling cylinder screen, and essentially that's what it is. And it has this menu system over on the right-hand side where we can go ahead and set up how we want to look at it. First of all, I'm going to set my reference curve. That's the curve that's going to be in the middle. My reference curve is my as-drilled curve in this case, and I'm going to set that to be my work curve, which is what I want. And then I'm going to look at my scan scope here, and I can see that that scan scope is for whether or not I want to look how far away I am from my proposal, or whether I want it to also measure how far away it is from some other curves. In this case, I don't want to have it just set up to look at my proposal. I have this other well over here, the green well that I have here too, and I want to make sure that I'm not going to go crashing into that. So then I've got this scaling down here, and the scaling is such that I'll give you an example of it. I'm at 4004 here, and all the distances that we have here are there. And you can see that these numbers out here are scaled for being pretty far out. And I'm just going to use the arrow keys on the keyboard. I noticed that I came over here and I'm actually working on the form behind here on my survey. And I move my surveys up so I can see how far away things are. This is called a mosquito plot, in part because when you jump through, these kind of look like swarming mosquitoes as opposed to a spider plot. That's my name for it, so that's the name. Since I wrote the program, I get to call it what I want to call it. At any rate, we have over here, down below here, this relative scaling, and if I don't want to have relative scaling, which means this most furthest point is always out here, I can set this radius here to say 50 feet. I'll set it to 40 feet. Okay. For a fixed, first of all I have to put it on fixed, and then I put it there. So that means that this outer boundary is going to stay at 40 feet. And when I'm moving along, then I can see relative to that 40-foot barrier how far away I am. And that's generally the setting that you might want to work with, but initially when you have it on relative scaling, it's always going to take whatever is farthest away and put it out there. And then you have this section down here where you have the different methods for calculating your distance. There's normal plane, which is the plane which is perpendicular to the direction you're going, and that's generally the one direction a driller wants to work with. However, it's not always the one. And then there's the TVD plane, and that's just something some people want to look at sometimes. When you're doing a horizontal well like we are right now, it's a very poor one to use because horizontal wells have a tendency to be on the same TVD plane, so it's not a very effective way of measuring it. So I'm going to turn that one off here. And so now we have a situation here where we can see that on the left-hand side I've got my proposal, and on the right-hand side I've got my green one. And if you recall, that's the way the plot looked that we looked at a few minutes ago. So I can turn on my other methodology here, which is my true minimum. And my true minimum draws a little circle with a number, a solid circle with a number in it. And it's in this case, the normal plane and the true minimum distances that are being calculated are so close as to be indecipherable from one another. But you also have down here an area where you can see how many feet right and left the curve is of the proposal. So if I'm looking over here at my curve number 2, I can see that my curve number 2 is right by 7.9 feet, and it's just slightly above my curve there in the normal plane by 0.29 feet. And these up-down numbers are really relevant only in absolute accuracy to the normal plane, although they have some, because the normal plane's they're going to be measured on that plane, whereas when we go to the true minimum, that's actually measured on a sphere. And although generally those numbers are going to be close, they're not necessarily, these up-down numbers aren't necessarily going to be as precise as they are with the normal plane. There's one more element here, when I notice it when I turn down the true minimum here, I turned it off just for the sake of illustrating this. And when I turn this on, it turns on this check crossings. And I turn on the check crossings, and now I'm going to illustrate what goes on with that. Notice that as I come down, that there's this next one that I've got in the middle here, this big circle here with an X in the middle of it. And what's that is telling me is that over the course of this next interval here, I have a crossing. That means that my black path is actually going to cross the green path, and that I have a crossing minimum here. And the reason crossing minimums are important is because crossings are where collisions have the potential of occurring. It doesn't mean that they are going to occur, but it does mean that there's a possibility that it will occur, and that's the point of interest. And it's kind of like a looking forward thing, and it's an important thing to turn on when you think you're in a collision situation. So you can go through all of this, set this up, and every time you go ahead and take a survey, you can go and play around with this screen, move up and down, and it gives you a really quick overview of multiple wells. So I'm going to close this out now, and I'm going to go to another form of if you want to get a report, and that's where you go to this reporting over here. The report is a least distance report. It's available here under the reports on the main screen. And here we have a reference curve and we have a comparison curve. So in this reference curve is curve 0. That's the one that we're concerned with. And we can only look at one curve at a time here in comparison. So I'm going to put in my proposed curve here. And then you can see that there's this list down at the bottom with the colored columns, and it has different alignments in it. And you have this north reference and south high side reference. Well, generally, directional drillers like to think in terms of high side, so it's easier to think like that. And when I do that, these numbers over here change around a little bit, but the azimuth and inclination change. I'm going to come down here, and I'm going to come down to the very bottom of this report at this survey at 4,000 feet, and we can see that this is telling us that we're 10.9 feet away, and that the azimuth for that point is 269, and it's at a 77.3 degree inclination from us, which means it's down from us. This is a little bit more obtuse to visualize than the normal plane visualization is, but the numbers, in particular the distance, is the important thing, and in what direction it is. But if you need to have a report, this is where you go to generate a report. If you want to go ahead and take a look at a traveling cylinder, you can do that. You choose the traveling cylinder, and you can calculate it, and it generates this plot for you here. And we can see here that I have a 200-foot radius, and I have all this clutter on the inside here. So I'm going to change this to a 20-foot radius. Hit a tab. I'm going to calculate this again. I still have all this clutter. So I'm going to expand the plot. Expand it. And when I expand the plot, this goes down, and each one of these is a TVD level, and we can see that at each one of these TVDs how we kind of are circulating around the target. The program uses an algorithm to kind of make these projected curves about how far away we're going and twisting. And you can print that out if you want and hide the plot. So if you want uncertainty, you can turn uncertainty on, and it uses only one methodology here, the Wolf of the Wart, which was the only air model that was around when this program was written originally, and that defaults to using MWD in the model, and then we can calculate that, and of course you can't really see much there. And you can start seeing these circles and how accurate they are. Who knows? You know, this, when you get into horizontal, this model starts getting really squirrely and whether or not they mean anything. So this is, I wouldn't put a whole lot of faith in the accuracy of the model. Never mind the these ellipses that are being drawn here. But you know, hopefully you won't have to deal with somebody that really needs to have that. If you do, you need to use Hawkeye or one of the other programs that are available for calculating that stuff. So the reports here can be, you can generate a pretty decent looking report there by hitting this, and you can also generate an ellipse report if you need to right here. All in all, you have a good set of tools for determining how far away you are from other wells. And I would like to express how important it is for you to know that the well that you are on, like well 0, you generally have as your reference with your north offset set to 0 and your east offset set to 0. And any other wells that you may be concerned with need to be placed over in these other curves, and the distance that they are from your well in terms of north and east needs to be put in here, and that's something that you need to get verified with your operator, with the people that do the well planning for you, and make sure that those numbers are accurate and that they're put in there. And also make sure that the RKB elevations that are associated with those wells are entered as well, because the RKB elevation for different wells obviously can be different because they're drilled with different rigs. Even though they may only be, a few hundred feet from each other, they're still, you can have a considerable difference. And in some instances, those differences can be critical. So it's important that you get those RKB elevations in there, because least distance calculations don't calculate TDD in east-west, north-south. They calculate sub-C, east-west, and north-south, and the distances of those, because of you have to normalize the space, and that's the way it's done. So that pretty much covers the explanation of the various tools that are available for calculating least distance.
WinServe has an assortment of tools to help you do certain types of things, and they're organized under this menu here called Tools. And one of the most important ones for you to use on a routine basis would be this interpolator here. And by selecting that, we come into this screen right here, and we can interpolate either on measured depth or TVD. The curve that it's interpolating is the one that you currently have selected, and in this case it would be interpolating off of curve 2. So if I wanted to interpolate something along the wall that I'm drilling, I would click on 0 first, in this case 0 being the one that I want to interpolate, and I would come here and I have a list of measured depths that are available in that survey. Then I can interpolate anywhere in that range. If I wanted to interpolate along TVD, then I would select TVD and I would interpolate along that range. Now, as an example here, what I will do is indicate how to say I want to know exactly 3,300 foot TVD. So I have TVD selected here. I come down to here and I type in 3,300 and then the tab key, and I see that I have an interpolated survey right here exactly at 3,300 feet. And maybe I want to make a new curve, or I want to make a sidetrack, or maybe I just want to insert that as the top of some formation. So I can put a comment here, and let's say this is the top of some formation. Okay, I put that tab in there, and then I insert, and that's been inserted in there. Let's go take a look at what happened there, and we'll go to 3300 foot TVD, and we see that we have a new survey which has been inserted in there, and that it has exactly the same dog leg as the following survey, which is what we should expect because it has to be interpolated based upon a minimum curvature method. So the next thing that I need to do is go back to this tool and show you one other very important feature of how to do things. Let's say we need to do a sidetrack. Now, WinServe makes it very easy to set up a sidetrack and do a sidetrack proposal in the field, and you would almost always start off with using this interpolator to do it. First of all, let's go ahead and decide where we're going to do our sidetrack at. Let's say we're going to sidetrack at a measured depth of 3,000 feet. So I'm going to choose measured depth, and I'm going to input 3,000 feet for my MD, and now I'm going to make a tie-in point. Well, here's a little test question for you. What is the best curve for me to put my tie-in point into? Well, as it turns out, the best one to do it would be the one where you're going to start your proposal. And if you don't have a well planning module turned on in your WinServe package, you'll want to use curve 21. And so I click on curve 21, and it gives me a warning that there's already something in there. And then I go OK. And so now I'm done. Let's go take a look at what we have in curve 21. Well, in curve 21, I've got my tie-in survey at exactly 3,000 feet measured depth. And I can start planning from that point onward to do a sidetrack. So to make my proposal, I first go ahead and select curve 21. And then I would come over and choose curve 21 projections. Well, most sidetracks will start off with a kind of nudge, and the best tool for doing that would be the Ouija board in its default setting, where I would say I want to drill off 50 feet, and maybe I want to have a 5-degree dog leg coming out 50 feet, and I want a 90-degree tool face. I'm going to turn out, I just want to turn right and get off this thing, get away from the fish or whatever it is that we have. And I look at that and I say, well, that's great, okay? And then the next step would be for me to go ahead and use the next projection. So in this case, I'm curve 21. I've added that in there, and I want to do a, let's see, DLS projection to target, and the target's at the targets at the end of the current well plan that we have. And so I'm going to choose a 3 degrees per 100 and see if that'll get me there. No, that's not enough, so too much angle there. 80 degrees, that looks good. I'm going to use 12 degrees per 100 to do that. And then I'm going to add, and should be done there. So now I've got in curve 21, I have a plan, and I'm going to go take a look at that, turn on my plot, turn on my curves, and I'm going to turn on curve 21 to see what we have there. So curve 21, as you can see, we've got a new line in there, and it's a different, this is a sidetrack, so we can't expect it to be exactly the same. We don't want it to be exactly the same in this case. But we have a sidetrack, so the question is what do we do with it now? We go to curve 21, click on that, come over here to the editor, go to the curve editor, remember how to copy this stuff, you make sure that it's selected there, and then I'm going to copy curve 21, say, over to 11, so this will be my new proposal that I'm going to use, and I'm going to keep it. Oh, I forgot to press the copy button, so I'm going to do this again, curve editor, curve 21, press 11, and then press copy, and then it should come over there. So now I have it in curve 11, and I can continue to use my curve 21, and I can label my curve 11 as sidetrack, and I can start comparing to that one. And instead of calling it a projection curve, I'm going to call it a proposal curve. So I come up here. And instead of referring to my new plan as plan 1, I'm going to come over here and change this to 11. And then that means that this plan that I'm currently going to be, the default plan that it's going to be working with is going to be 11. 1 is going to be the original. So I can come over here and I can go original. And so now this is the new one here. And so now when I go to do my plot, I can now go to my curves here, and I no longer need to be looking at this one. I'll look at this one and turn that off, and I'll turn this on and make that one the red one now. So at this point we have created a sidetrack proposal, and it is registered over here as curve 11, and we can, you know, keep a record of the changes of what we do. Now if you're drilling a lot of sidetracks and you have up to 20 curves here to work with, and if you need any more than that, then you need to start another file and have a continuation. But it's rare that, at least in the drilling oil wells, you'd ever have that many. It sometimes does happen, however, if you are doing coal bed methane drilling and you have a lot of little turns and whatnot. The next tool that we're going to discuss here is a useful little tool here that you may want to use on occasion. It's called the DIP DLS calculator, and it is a very neat little tool. It's kind of inspired by a tool that was developed for another program. And the idea behind this is that what you can do is you can specify curves. Let's say the question is that you want to know how much departure you're going to have if you have a build rate of 12 degrees and you have a start angle of 0 and you want to go out to 88 degrees inclination. You've defined 3 primary variables, and now you want to calculate. So you calculate it, and you can see that you have this little diagram over here that's color coordinated with what you have over here in your variables. But it's showing us this line down here at 90 degrees, and we really want to have a dip angle of 2 degrees because we have an 88 degree landing there. And so when we do that, then we can see how much RKB TVD we have in our elevation there above this dip. We've got 461 feet. We have a displacement of 460 feet and delta TVD of 477 feet. So you have all these numbers, and these are things that in your pre-planning or you just want to get a good idea of a needed build rate or something, you can use these tools. Now this particular little calculator will let you solve things, and you have to have all 3 of these up here, or any 2 of these in this area up here at the top. For example, let's say that I want to know what build rate I need to have to go from 0 to 88 if I'm going to have a displacement of exactly 500 feet. Okay, I need to be 500 feet out, and before I can calculate it, I need to get rid of any extraneous information that is going to be here before I can calculate, because if it's overspecified, it doesn't know what to calculate. So I have to erase things until I get this to come on, and then I can press the calculate button. And it's telling me in order to get exactly 500 feet to go from 0 to 88, then I would need a build rate of 11.05. And so let's say that I need to do change that a little bit. Let's say I need a delta TVD of 500 feet. Okay, so I can put 500 feet in there, and I can erase this MD here. And I need to erase the unknown up here. Notice this still isn't lit up, so I turn that off. Now it's lit up. Now I can calculate it, and it tells me I need 11.45. So this tool is neat, and if you change your end angle, let's say you're going to do an 85-degree thing here, 85-degree landing angle, then that means your dip is going to be 5. And so I would erase all this stuff here, and including this. And now we can calculate. And now we have a 5-degree dip down here. And so this is a tool that you can play around with. If you're going to be working in feet, keep this in feet. If you're in meters, put it over into meters, because your numbers are calculated, your build rates are calculated differently.